Section 3.5 of our Algebra 2 BJU textbook. We're going to take a look at some special functions. To review, the very first function that we learn about is a linear function. And it's the form of y equals mx plus b, where m and b are real numbers. It's a line. It's what the graph looks like. So an example of a linear function is when you're traveling at a steady pace. So as x increases, so does y, but at a steady pace or at a steady slope. So as time increases, distance increases at a steady pace. Then we have what's called a constant function. A constant function is a little different because it looks like this, f of x equals b, where b is a real number. So this would be like y equals 2, or y equals 5, or y equals -3. So because there is no slope, or the slope is 0, that means that it is a horizontal line, and that horizontal line is going to be at y equals 3. An example of this would be if you have a cost of something, and even like after so many years, like the price is still the same, the price doesn't change regardless as the time passing. That's a good example of a constant function. So for example, let's say the price was $3. So even after 1 month, it's still $3. 2 months, still $3. 3 months, still $3. So let's take a look at another type of function or a equation. We have x equals b, where b is a real number. So in this case, our y is not there, which means that this is a vertical line, which means slope is undefined. Well, if it's a vertical line, that means it doesn't pass the vertical line test, which means that it's not a function. So it's not a function, x equals 3. It is a vertical line, and it's going to be a vertical line at x equals 3. Our next type of function is an absolute value function. So for the absolute value function, you'll notice as you plug in values, no matter what value you plug in, you'll get a positive number. So -2 goes to 2, and then 2 goes to 2. -3 goes to 3, and 3 goes to 3. So you end up with a graph that looks like this. It's kind of like a V. The next special type of function I want to explain to you is called the greatest integer function. And this function looks like this. So notice that there are brackets around x here. So this is the operation of greatest integer. And so this is what this says. Your y values, so what you're equal to, f of x, your y values are determined by choosing the greatest integer, which is a positive or negative number, that is less than or equal to the given x value. So for example, if our x value is 3, our y value would be an integer that is either 3 or less than 3, so it would be 3. If you have 3.4, 3.4 is not quite 4 yet, so that means that our y value would be 3. 3.8 would still be 3 because you're not yet to 4. When you get to 4, then your y value is 4. So even 3.999999, your y value would still be 3. And then after you have passed the 4, and you go on to 4.1 and 4.2, then you start over. Then you're back at 4 all the way until you get to 5, and then you move up to 5. So we call a greatest integer function, another word for this is called a step function. And the reason why is because if you were to look at the graph, remember, you're going to be y equals 0 until x equals 1, and then you get to jump up to 1. And then as in between 1 and 2, you're at 1 until you get to 2, and then you get to jump up to 2. And so your graph ends up looking like this. So again, here's 0, 0, and then when x is 0.5, you're still at 0. When x is 3/4, you're still at 0. But when you get to x equals 1, then you get to jump up to be at 1. So this is what our graph looks like for the greatest integer function, which is also called the step function. The next type of function we have is exponential. Exponential is where you have some real number for your base, and then your x is going to be your variable, but x's have to be a real number. Also, your a cannot be equal to 1, and your a has to be bigger than 0. So your a can be a fraction, it just can't be 1, and it can't be less than 0. So an example of an exponential function would be 2 to the x power. And if we were to graph this, so exponential functions always cross the y-axis at 0, 1, because if you were to plug in 0 for x, anything to the 0 power is 1. So that means all exponential functions cross through 0, 1. Okay, so examples of an exponential function is if you have population, bacteria, inflation, all of those grow exponentially is what we've heard of, and so those are exponential functions. So as time increases, population or bacteria, inflation, it's going to increase at an exponential rate, so it's an exponential function. Some more examples of exponential functions is radioactive decay. This is actually an example of exponential decay because as time increases, your y is going to decrease. Our next type of special function is a quadratic function. It looks like this. Y equals ax squared plus bx plus c. So in this one, you have a variable x, and then your exponent is always 2. A, b, and c are going to be real numbers. So an example of a quadratic function is a path of a projectile. So for example, a baseball, an arrow, a rocket, anything that goes up and then goes down, or goes down and then goes back up. So as time increases, your distance increases and then increases and then goes back down. So you have to be able to identify different types of functions. So let's try this one. F of x equals the absolute value of x plus 7. So your Q right there, those absolute value symbols, this is an absolute value function. So the little brackets, remember, that tells us it's the greatest integer. Negative 2x plus 9. So this one looks at the form y equals mx plus b, which is linear. F of x equals 3/5. So notice that there is no x term, there's no x term, which means that this is a constant function. F of x equals 6 to the x power. So remember, when x is in the exponent, you've got an exponential function. All right, now we need to be able to evaluate the function. To evaluate the function, you substitute a value in for x. So for x equals -4, you'll plug in -4, so you have f of -4, and then -4 plus 5 is 1, and the absolute value of 1 is 1. If we were to do the greatest integer for -4 is -4. For 14 over 5, so 14 over 5 as a decimal is going to be a little less than 3, which means the greatest integer it could be would be 2. 3 to the x for x equals 4, so to evaluate you would do 3 to the 4th power, which is 81. 1/3 to the x for x equals -3. So you would do 1/3 in parentheses. Notice the use of the parentheses to the -3 power, and you would get 27. Go ahead and try some problems on your own.